The charity is assigning volunteers to work at its booth at a fair that runs 3 days, Thursday, Friday, Saturday. Alright, so at this point in the game, I'm already anticipating some ordering elements because Thursday, Friday, Saturday are inherently ordered, right? You're not going to write Friday, Thursday, Saturday. So if it turns out to be just a simple old ordering game, then I would do Thursday, Friday, Saturday. If it ends up being a hybrid game that has grouping and ordering mixed in, I'm still going to do Thursday, Friday, Saturday because in hybrid games you want to focus on the ordering aspects of the game first. So without even going any further, I'm just going to write Thursday, Friday, Saturday because it's highly unlikely that we're going to do this any differently. The five volunteers are being assigned. LMNPQ, LMNPQ. Okay. Then it says on each day, exactly 3 of the volunteers will work at the booth. Okay, each day exactly 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3. What do we know at this point in the game, given the fact that we have 5 volunteers and 9 slots?
It will be reused.
Somebody's got to be reused, right? Now, maybe one person, in theory, goes 9 times. Is that possible at this point? It says 5 volunteers are being assigned. That sounds like everybody's got to go at least once. Because if you're going to have 5 volunteers, that's a little ambiguous. But anyways, let's keep going. The assignment of volunteers today must meet the following conditions. No volunteer works every day. Okay, if no volunteer works every day, then you can't see a volunteer going 3 times, right, across the board. Let's think about the numbers here for a second. So that means the most that any volunteer could go is twice. Okay, so that significantly reduces things, right? So how many people do I have to use?
9. All.
But you have to all 5 of them, right? Because if if everybody's limited, we have 9 slots and you have 5 things. 4 people could go twice. That's 8 plus 1 more. That's 9. Right? Since people can't go 3 times, we're going to have to use everybody. So no matter how that initial sentence can be interpreted, we now know that everybody goes and only one person goes once. And everyone else goes twice. Because there's no other way to fill up these 9 slots. Is anyone confused by that point? So one thing,
I'd like, would it help to create an outgroup without 10th? Or does that not?
Yeah, you could think of it that way. Actually, that's kind of interesting. You could say, hey, look, I have LMNPQ, and one of these individuals is going to go out. I didn't do that, but I was more thinking, okay, one person's going to go once. But another way of thinking about it is one person is going to go out. Kind of means the same thing.
It helps with 20 and 23. I want to play it through and see if it does the rest.
Okay. On any day that M works, L works also. So if you have M, then you have to have L on that day. N works on Friday. Okay. That gets rid of one of our N's. And P does not work on Saturday. Okay. We got the rules down. What are some things we can do with these rules before we go into the questions? General principles. One general principle that we talk about a lot is
Turn negative to positive.
take negative to positive, right? Now this negative rule right here says P can't be on Friday or Saturday, so that means P's got to go at least once, so P is going to be here or here. If it goes twice, it's on Thursday, Friday, right? So that's one positive interpretation. It's not the only positive interpretation of that rule, though. If P does not go on Saturday, who does? Okay, so now this might seem a little ridiculous. You say, wait, okay, M, L, N, and Q, but it's not totally ridiculous because that's 4 people and there are 3 slots. So really what we're saying here is that one of these individuals is not going to go here. Can we say anything else about that group of 4?
We need M.
We need M?
Yeah.
Why? Because it takes up 2 slots?
Yeah, M and L.
What if you, okay. What if you did Q and L? I guess you could do that. Yeah?
It's actually you need
L needs-
L, not M.
Yeah, L needs to be there because if M is there, then L needs to be there, and then if M isn't there, then L needs to fill the 3rd slot. So
That's right. So if M is there, then L has to be there. If M is not there, then all you have left is these 3, which would include L. That's a super common thing in the games. If you have an if-then statement, and it says like this, if M then L, then this becomes the necessary condition, which means, in a lot of cases, it's going to be the thing that's required to go there. Because you run into this situation which we're running into right now, which is, if you have M, then you have L. And in this case, if you don't have M, you get rid of M, you still have L. Not because of that rule, but just because that's all that's left, right? Now that doesn't always happen, but it's like a trigger. Like when you see this, you should be like, okay, exclamation point, what does this imply? That doesn't have the same implications for M because L can go places and M doesn't have to be there. But if M goes, then L has to be there. So L is more likely to show up in places and be required to go there. Is anyone still confused as to why L has to go on Saturday? A little bit?
Is it just because you couldn't fill it with M and Q? You couldn't fill it with any other options, basically.
Yes, but let's make sure you're getting that. So these are the only variables, right? So why in your mind does L have to be on Saturday?
I don't think it has to be.
You don't think it has to be. So
Sorry.
that's okay. That's right. So L does have to be on Saturday, and here's why. So let me just this little OCD here that's bugging me. But this are you cool with the fact that these are the only people that can go on Saturday?
Yeah.
And you're cool with the fact that we have to have 3 on Saturday.
Yeah.
Right. So that means of these 4 people, only one of them is going to be able to walk away. Right. And the other 3 are going to have to go on Saturday. So if M walks away, then these 3 are left, right? And they go. If M doesn't walk away, if M stays, what happens?
You have to have L.
You have to have L. So if M is gone, L is there. And if M is here, then L is here. So no matter how I try to arrange these variables, among the variables that are there, L is going to be there.
Oh, okay, sorry. That makes more sense.
Cool, cool. So I'm going to go ahead and put L here, and now I can get rid of one of my L's. And this has, you know, although the rule says if M then L, it doesn't say if L then M, so I can't put M here. But if you know that you have both M's, what do you know?
You have 2 L's.
And they have
You have 2 L's, and that's absolutely
One
right.
M is in Saturday.
One's got to go. M's got to go on Saturday because if M shows up twice, it's got to show up with an L, right? Whereas if M only shows up once, then okay, I could put M over here with L, and then this could be L by itself without M, right? But if I have 2 M's, since I can only have at most 2 L's, the M's have got to go with the L's. Okay. That's kind of big. So we took a negative rule and we turned it into a positive rule. Let's see if there's anything else we could do. I mean, you could do worlds. You could say, okay, M is helpful. But even then, when I was running through this, I was like, I could do M, M, M. I can't do M, M, right? Because you have an L there. But you could do M, M. You do M by itself. And you could do M, M. That's 3 worlds. Anyone do 3 worlds? Or worlds on the basis of something else? No? Well, it might be worth trying to do this game on the basis of M. Again, the only options would be M, 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 and then just M by itself there. No, actually M could go by itself there. Forget it. Okay, 18. Which one following could be the assignment of volunteers for Friday and Saturday? Is this our traditional first question?
Not really.
Not quite.
No, technically no, because they're partial answers, right?
2/3.
But it's 2/3. Might be easy enough. What's an easy rule to apply to these?
N has to be in Friday.
Okay, and it has to be a Friday. Excellent. What does that get rid of? I hear a vote for B. Yeah, N is not on Friday and B, so B is out. Okay. We also have if M then L, right? Is that going to get rid of anything? Do we have M without L?
Yeah, E.
B. Oh, E, right?
E.
Yeah, okay. And then what else? We know that P can't go on Saturday.
Unless have A violates the rule that you can't have 3 go all weeks. MMM.
Yeah, so for answer choice A, you would have to put,
Oh no, wait.
you only have 2 left, right? You have Q and P left. So then someone would have to go twice on the same day or something like that. So A is not going to work for that reason. C and D, what's left here?
K isn't on Saturday.
Oh yeah, P is on Saturday, right? That's not good. So that's going to get rid of D, and we're left with C. Okay, cool. So we can still use process elimination, even though it's not our traditional first question. I would skip ahead and do the if questions because we don't have worlds. 19, if P works on Friday, then any of the following could be true except. Okay, well if P works on Friday, if P comes over here, do you see anything that can't happen? And it could be true except. P goes here,
M can't go on Friday.
M can't go on Friday, right? Like, okay, let's hope to God that if God, LSAT God exists, let's hope that's the answer. Because that would be easy, right? And thank God they have an answer that says M is on Friday. Think the D. Oh, yeah, that's true. You could do that too. Okay, so that's the answer. Questions on that one? All right, let's keep going. 20. If P works only one day. Okay, if P works only one day, do we know what day P is on? At first glance. No, I'm like, it could go either way, right? But we do know that everyone else goes twice. So who do we want to start with?
M.
M, because M has the most impact, right? So if everybody else goes twice and L is here, I now know M has to go there. And I still don't know where M goes because I was like, okay, well ML or ML as far as I can see. So
Well, then you'd have 3 L's. If you did ML.
no. So I'm saying one of them goes here,
Oh,
But you need,
but I don't know whether M goes here with L or M goes here with L.
but if you look at the answers, that's all you need.
It's all you need. Again, you're like, LSAT God help, because I saw that, right? And I'm just wondering if there's anything more, because if there is anything more, then I do want to make those inferences, but if there isn't, then I'm going to stop and look at and see if that's enough, right? And here, where are we on? We're on 20, right? Yeah, M works on Saturday. Okay, good. That's the answer, right? Now, sometimes we jump to the answers too soon, and we're like, okay, now we got to go back and do more work. So I'm always trying to see, can I go any further? But if I don't see anything, then I'm just going to drop down and see if that's enough. 21, completely determined. This is not an if question. 22, if M works on Thursday, which of I must be true? If M works on Thursday. Okay, well, if M works on Thursday, we have M, L. Great. Well, 1, 2, 3, 1, 2, 3, 1, 2, 3, M, L, N, L. And we still have P going back and forth. Anything else? So we got a couple options here, right? One is that if M goes twice, what do you know?
Has to go Saturday.
Has to go Saturday, right? If M doesn't go twice, what do you know?
It has to go
Has to go
Saturday.
Saturday.
Everything else goes twice.
Wait,
Yeah,
if
go
M
Saturday.
doesn't go twice, it has to go Saturday? That doesn't make sense. If M doesn't go twice, then P goes twice. I'm just trying to get rid of this like uncertainty, right? So if P goes twice, then both of those are going to be filled in. All right, so we could do 2 worlds on the basis of that. Let's see. Yeah.
I was just gonna make it inferent, like, because wouldn't Q need to be on Friday in that circumstance, like regardless of whether or not M goes?
Yeah. So if you're willing to play this out in your head a little bit, if M goes twice, M goes here. You the only thing you have left is P and Q, and they would both have to go there, right? Because the M and L's, both of the M's and the L's would be gone.
Mhm.
So you would put Q here in that circumstance. Now, if M only went once, and you had P, you still have L, you're gonna still need Q there, right? So in either circumstance, Q has to go on Saturday or Friday, right? Did you see that? That's great. And so we're just getting there by trying to see who's left, given what we know. You guys comfortable with that inference?
No.
Okay.
I don't understand why it can't go Saturday.
Oh, I'm not saying it can't go Saturday.
Oh, but it has.
So think about it this way. So you have ML, right?
Yeah.
If M goes again, it's going to go there.
Mm-hmm.
So that means it can't go here. N can go again here. And so that's 2 down. We have 3 left. L can't go again here because we've already done L twice. So the only things that are left are Q and really P at this point, right? So what we're trying to do is basically ask ourselves who's left and what do we know about them. By the way, does that mean that P has to go here though?
No.
No, not necessarily. So I'm going to actually move this over there. All right, so at this point, we do know this could be P, it could be N, it could be Q. Really, it could be anything. Okay. Which of them must be true? L works on Friday. No, it can't work on Friday. M works on Saturday. No, it could, but it doesn't have to. N works on Saturday. It's a good question, actually. Well, we could have N here, and we could do MQ, right? So nope. P works on Thursday. Again, we just saw it doesn't have to. Q works on Friday. That's what we already figured out. That's the answer. Okay, 23. If M works on only one day, which one of mine must be true? Okay, if M works only once, well, here's a situation where M could be working only once. We know that, well, first thing we know right away is what? If M works only once?
It's working on Saturday.
Not
He's on-
necessarily,
He's
actually.
on Thursday and
Oh.
Friday.
Because M does require L, but it could be on Thursday or even Friday. P's got to go twice, right? Everybody's got to go twice except M. So now we know P is on Thursday, Friday. Do you see any other obvious inferences from there? Well, we know M can't go there. So if M goes once, it's either going to go here or here. All right. What question is it? 23. Which of mine must be true? L works on Friday. No, not necessarily. Could. M works on Saturday. Again, we just talked about it. Could. N works on Saturday. Could. P works on Thursday. That's got to be true because of what we just figured out. P's got to go twice. So D is the answer for 23. We're left with 21. The assignment of volunteers is completely determined if which one of the following is true. I would like something that deals with M because M deals with L, right? Okay, so there's only one answer that deals with M actually. B. Let's start with B. M works on Friday. So if M works on Friday, what do you know? L works on Friday, which then forces P over here, and P is going by itself, and it's only going once, right? Not by itself. It's only going once. So if P is only going once, what do you now know?
Everything else goes twice.
Yeah, now normally I wouldn't write on my original diagram, but this is the last question for us, so I'm going to hijack it. So if M goes here, this is actually starting to look promising. L goes here, P's got to come over there, and then we now know everyone else goes twice, including Q, which has got to go on both sides here. Q. And M's got to go twice, and M can only go Saturday because it's got to have L, right? And then N is the remaining variable.
Could you explain how you knew? I understand why the diagram works out the way it does, but how did you make the inference that Q went on had to go Saturday, Thursday?
Oh, so originally we had N here,
Right.
and we put M here because they told, that's what we were trying. So we put M out, and so there's nowhere else for Q to go. So then Q's got to be split up, M's got to come over here because it's got to be with L.
Gotcha.
in this case. Don't misinterpret that rule. I'm not saying if L then M, I'm saying if M then L, but in this case, if you're going to put an M somewhere, it's got to be a place where L is. So, we got to put it over here. And then, yeah, P moved over there because we didn't have any room on Friday. Yes.
I have a question about these questions generally.
Sure.
This one was pretty easy because it like had a restricted rule, but in general they like take up a lot of my time sometimes when I can't see the inferences. Is there like a way to do this without like I
Yeah.
don't know, like going through each?
So a couple things. One is you do want to look for these restricted rules. You also want to look for sometimes there's like floaters, and pinning down the floaters can be helpful because you're like, I don't see any other way to pin these down, and so if we pin that down, maybe that will start helping things to happen. Another thing that you can look for is, I was just thinking of it, now I forgot. Dang it. Oh yeah. You can look at previous diagrams. And you can say, hey, there's a previous diagram. Like for example, I think this one works. Take a look at answer choice A. Answer choice A says L works on Thursday. I'm like, yeah, I've seen L on Thursday and that didn't finish everything out. So you can just look at diagrams that you've created before that aren't complete or that have things that are moving around in the diagram and get rid of answer choices that clearly did not force everything else to take a certain action.
Thank you.
Yeah. All right, any other questions? Yeah.
I think one inference you made that, because I was very much not really sensing the same patterns that you were, and like for every single answer, even on the ifs, it was like I was redrawing and trying to refigure out
Sure.
the whole problem. For like this sort of hybrid game where I didn't make the same inference that, okay, everything has to go twice except one, and then
Yeah.
on Saturday it has to be one of these four, and it can't, and it has to be L.
Yeah.
Do you think it's worthwhile, like before you get into the questions, if you have a question like this where there are a bunch of spaces and not a lot of variables and you know you're going to fill it up, to kind of get a sense of, okay, things have to be used this many times?
Yes, for sure. So that's a pretty common thing in grouping games. Now this is a hybrid game, but that means it's also a grouping game. So in grouping games, when the number of variables is used more than once, or less than once. You know, in most games, it's like every variable is used exactly once. You're like, okay, great, simple, simple, simple. But when that is different, you want to try to pin down what's going on. Because a lot of times it feels like, oh, there's so many options. But when you start thinking about it, you're like, oh, there's only one or
That's
two
how
ways.
I felt like there were too many options. I was like, oh my god.
Forget it, just go, right? Yeah. And so it's weird. Like, if you sit there and think through it, you may think, okay, well, I could do a 4, 2, 1, 1, 1 or something like that, and then I could do a 3, 3, 2, 2, 2, 2, 1 or something. Like you start running through them, and maybe you do realize, oh wow, there's like 5 or 6 ways. But in most cases, you end up realizing there's only 2 ways. Here, there's only 1 way. But a lot of times, there's only 2 ways, and you're like, oh, maybe I'll create worlds. One where they have this many, and one where they have that many. So I would run through it, just at the bare minimum. Any other questions? Okay.